So why don't we let u be the radicand, like this here. And then if you solve for x, get x alone, you'll see that x alone is this. And then if we get du, du would be 2x dx. Now if we get dx alone, that's du over 2x, which is dx. But then we can replace x with the square root thingy. So that's 2 square root of u minus 4, and all that equals dx. Now let's go back here and make some replacements. So the numerator is the square root of u. And then x in the bottom is the square root of u minus 4. And then replacing dx is this fraction there. And let's totally clean this up here. So we can take out a 1/2 to the front. And we can call this the square root of u over u minus 4 du. And then from here, why don't we let w represent the square root of u? That would tell us that w squared is u. And then dw, the derivative of that would be 1 over 2u to the negative 1/2 du. And then if we get this du alone by multiplying by 2 and multiplying both sides by this, that should give us 2 u to the 1/2 dw equals du. You want to confirm that you know how to go from here to here. Now, let's go back here. So this is 1/2 integral. So in the top, the square root of u is w. And in the bottom, that u is w squared minus 4. And then replacing du is 2. Well, how about this? How about here? We do something here. Less 2. Now, u to the 1/2 is the square root of u, which is w. And all that's going to replace du, which is right there. So this would be like a 2w dw. And this 2 knocks out the half. That w becomes w squared over w squared minus 4 dw. So let's go long division. W squared plus 0w plus 0 will be divided by w squared plus 0w minus 4. W squared goes into itself once. 1 times that is all of that. If you subtract these, you get 4. So it's going to be 1 plus 4 over the divisor. So what we're saying is that this box in here gets replaced by this here by substitution, because this is equal to that. All that becomes the new integrand. We have this here. And now I want to remind you of another FYI. Recall that 4 over w squared minus 4, you can actually break this up into partial fraction decomposition. Recall that w squared minus 4 is the same as w plus 2 times w minus 2. And if you let this equal two fractions, let's let this equal a fraction, a over w plus 2 plus b over w minus 2. If you recall the idea of partial fraction decomposition, you will see that if you solve this equation for a and b, it will turn out that a is negative 1 and b is positive 1. Partial fraction decomposition to go from here to here. So in our integrand, the 1's chilling, it's going to stay. But this bubble here, that bubble gets replaced by these two pieces by substitution. And then we can finally find antiderivatives. The antiderivative of 1 would be w, and then minus natural log w plus 2, plus natural log w minus 2 plus c. And then all these w's, all the w's get turned into square root of u. All of the u's get replaced by x squared plus 4. And so here down below, we get our final answer.